New Zealand stands alone in the South Pacific. It's an ancient land. With ancient wildlife, strange insects, frogs which carry their young, and birds which can no longer fly. The Kiwi is not only our national symbol, it also symbolizes the very special wildlife of New Zealand. Why is the wildlife of New Zealand so different? Why are there so many strange birds and yet only one mammal, a tiny bat? The answer lies in the land itself. As we come to understand how New Zealand developed, we understand more about the extraordinary link between its geology and the plants and animals on it. These volcanoes haven't always been here, nor has New Zealand. New Zealand was once part of the huge continent of Gondwana. When it split apart, seafloor spreading, or continental drift, rafted New Zealand away. Continents move. They ride as passengers on massive, slowly shifting plates which cover the Earth's surface. New Zealand straddles the boundary between two of these plates. Their movement has caused our dramatic geological history. Volcanoes and earthquakes often go hand in hand. It gets pretty shaky here at times. That's because plate movement has created faults in the land. The shocks you can see here, curving down to the left, trace the line where the Pacific plate is sinking under the Indo-Australian plate. As the seafloor descends into the mantle of the Earth, it melts. The liquid rock is erupted as lava or volcanic ash. Mount Norohoi is one of these volcanoes. It's comparatively young, only 2,500 years old. Its major recent eruptions in 1948 and 1955 were spectacular, with lava flows and huge ash clouds. In 1975, it erupted again, this time showering the landscape with incandescent rocks, but no lava. Dramatic as they may seem, they're tiny compared with past eruptions. Movement of the Earth's plates has a more spectacular effect here than almost anywhere else in the world. This may look like ordinary farmland, but these paddocks are on the move. On the left is the plate of the Earth's crust that carries India and Australia. On the right is the Pacific plate. This is the Alpine Fault, where the South Island is tearing apart. Geologists discovered just how much the two plates have moved by looking at rocks on either side of the fault. Red Mountain in southwestland is red with rust because its rocks contain a lot of iron. Being barren, it stands out from the neighboring mountains. Near the top of the South Island, there's another one just like it. Dun Mountain, or Dun Saddle, is also rust-colored and barren. Its rocks are similar in age and composition to those of Red Mountain. So what, you might think? From a satellite, we can see the extraordinary movement that has occurred. If we reverse the movement of the Alpine fault, the two plates on either side once lined up like this. Over the last 50 million years, the two mountains have moved apart 500 kilometers in this direction, and they're still moving. You can see it clearly where the Awatere River follows the weakness in the rocks. Red rocks like those of the two mountains are found in other places too, and when they're plotted on a map, they tell us even more about New Zealand's past. The two curving red lines show where they're found today. And if we go back in time, we can see how the shape of New Zealand has altered. The present-day coastline is a reference, but of course it's changed too. The lines join and straighten, showing that the red rocks were formed when part of the sea floor was pushed against a string of volcanic islands 200 million years ago. New Zealand as it is now didn't exist, but we know where some of its rocks originated. The Takatimu Mountains in Southland provide a clue. Their rocks were formed at the same time as Red Mountain, under the sea close to the shore of Gondwana. Geologists know this because this is where they found a leaf which had sunk and been fossilized. What has a leaf got to do with it? Well, this leaf is from the plant Glossopteris, and it's also been found in Australia, Antarctica, India, Africa and South America, the lands which once formed Gondwana. So that's how geologists know that some of our old rocks come from Gondwana. This is where New Zealand started. Few plants and animals from Gondwana survive on today's continents, but many have survived here due to New Zealand's long isolation. Many of our trees, like the podocarps, are primitive relics from Gondwana. Isolation and the absence of tree-browsing mammals have enabled them to thrive. There are more than 35 kinds of the ancient Dracophyllum. The many tree ferns which we may take for granted date back 350 million years. Liverworts are even older, and amongst them lives another relic from Gondwana, the extraordinary Peripatus. It looks like a kind of caterpillar, but in fact it's the missing link between segmented worms and the joint-legged invertebrates like slaters. It's also found on other Gondwana countries. It feeds at night, entrapping food such as insect larvae or termites by spitting a sticky stream of slime which hardens around its victim. Peripatus then cuts a neat hole in the body wall and sucks its prey dry. Birds and insects on Gondwana often took the role of browsing mammals, which evolved late. The ancient flightless weta is New Zealand's largest insect, as big as a man's fist. Sometimes called an insect mouse because its habits are similar, it even produces rodent-like droppings. It feeds on vegetation and debris from the forest floor. It may have mouse-like tendencies, but it certainly doesn't look like one, with its thorn-like spines and armor-plated body. This living fossil is the most ancient of all living reptiles, the sole survivor of a whole order of beakers. The Tuatara was on Gondwana when the land that was to become New Zealand was still under the sea. Then, from 140 to 110 million years ago, the Pacific seafloor plate began to push down beneath the edge of Gondwana, building up a chain of volcanic islands with successive eruptions. As the ocean floor moved towards these islands, it carried with it old volcanoes, rock eroded from Gondwana, and sea sediments. These sediments were too light to sink below the land, so they began to pile up in crumpled layers until they formed a chain of mountains above the sea. The folded sea sediments, greywackies, now form a major part of New Zealand. Geological processes are unimaginably slow, and over millions of years the mountains eroded. By 80 million years ago, those first peaks were mostly worn down to sea level. The sea began to encroach on the land. And around 80 million years ago, the most important event in the history of New Zealand began to take place. "80 million years ago, India and Africa had already split away from Gondwana. Before South America, Australia, and Antarctica began to break apart, an undersea fissure appeared between Australia and New Zealand. Fresh sea floor was extruded from the fissure, and between 80 and 60 million years ago, the Tasman Sea was created. New Zealand was adrift with its primitive wildlife. There were no mammals, marsupials, or snakes at this time, and so New Zealand was without these influential animals as it began its slow journey to where it is today. Cut off from the rest of the world, the travelers on this small land were free to evolve in the Kiwi way. With them came an animal whose behavior is still rather puzzling: Archie's frog. For 6 weeks during the summer, with no water in sight, the male sits in a hole brooding a clutch of eggs. The tadpoles develop within the eggs. You can see this one's heart beating. Slithering in a slimy fluid, this is the closest they ever get to swimming. When the larvae hatch, they still have large yolk sacs attached, and they wriggle up onto the back of their father to complete their development. There's not a croak to be heard. Archie's frogs are silent. They have no vocal sacs and no eardrums. It's the most primitive frog in the world. Early scientists wondered how frogs could have reached New Zealand in the first place. But now we know that along with the Kiwi, they've always been here, and it was New Zealand that made the move. Our oldest native trees are also survivors from Gondwana. The kauri has relatives in Fiji and Australia, and it's the largest tree in the world by its sheer bulk. It sheds its bark to keep the trunk clear of climbing plants, a handy trick, helping it live for 2,000 years. The ancient southern beech is found in several Gondwana countries. It flourished here in the cool, wet southern climate. With these relics came many plant parasites and some peculiar insects. You can see why this one's called the giraffe weevil. And it comes complete with its own parasitic mites clinging to its armpit. Its snout, or rostrum, is used for boring into rotting trees. Those elegant antennae are halfway down the female's rostrum, but are set right on the end of the male's. This was above all a land of remarkable birds. They were evolving to suit this island sanctuary. Some flew less and less. Some lost their power of flight. With no predators, there was little need to fly. So the kōkako came to scuttle through the forest like a squirrel. Now, however, its feeble flight is no match for rats or the possums and logging which destroy its food supply and forest. The kakapo is one of the most unusual birds in the world. This flightless parrot lives in a burrow, and it emerges at night to feed on tasty vegetation, a sort of bird rabbit. It seems to live almost in slow motion. This is the heaviest parrot in the world. Its long life and large size are the result of its isolation. Now, being so helpless, it may join other flightless birds in extinction. Among New Zealand's many birds, none is more peculiar than the kiwi. The kiwi, more than anything else, shows the effect of New Zealand's long isolation on its wildlife. Although flightless and burrow-dwelling like the kakapo, it can move at great speed. It strides out of its burrow at night in search of worms, insects and grubs. It can't see very well, but it knows where it's going, for the kiwi has a well-developed sense of smell. This is most unusual, more a characteristic of mammals. And there are many other unusual things about the kiwi. The size of its egg is extraordinary. Comparative to the bird's size, it's the largest egg in the world, a quarter of the female's weight. Each is incubated only by the male for 2.5 months. When the chick hatches, it still has a large yolk sac underneath its stomach. It's absorbed over the next few days. The legs become enormously strong. 1/3 of a kiwi's weight is in its legs, and the sharp kick of the powerful feet is used in defense. But some of the kiwi's juvenile features remain into adult life. The feathers are very soft. They're more like hairs. It has cat-like whiskers and acute hearing, more features which resemble mammals. New Zealand's isolation gave protection to the birds and animals, and the land kept changing. The original volcanic islands were slowly invaded by the sea. In many places, the forests became swamps. As the trees and tree ferns fell and rotted, they were covered with silt and eventually buried deep underground, where pressure turned them into coal. This coal seam, now exposed by the sea, was formed 50 million years ago. 30 million years ago, in the shallow, calm seas around the drifting islands, the skeletons of many marine creatures built up on the seabed and gradually formed limestone. When the seabed rose, great limestone formations became part of the landscape. Rivers and rain, slightly acidic, began to etch down into this rock. The Oparara River, north of Westport, has dissolved a massive tunnel through the limestone, 200 meters long and 37 meters high. On a world scale, it's unrivaled. Limestone caves provide an anchorage for glowworms. The tiny green lights belong to thousands of fungus gnat larvae. The fungus gnat looks a bit like a daddy longlegs and lives in or near cave entrances. Each larva spins up to 70 long lines of silk covered in tiny shimmering beads. They hang like a natural chandelier, awaiting passing insects. Of a primitive snail, Pauliphanta. The calcium in the limestone country helps in the development of its enormous shell. Pauliphanta was a fellow traveler of the Kiwi on this drifting land and has grown huge in isolation. Some have a shell as big as a saucer with a thick, glistening body to match. There are over 40 kinds in New Zealand, all with strikingly patterned flat-coiled shells. Pauliphanta lays large, hard-shelled eggs. Like the kiwi, the incubation period is long. They take several months to hatch. But the most bizarre thing about these snails is that they eat flesh. At night, they drag large worms out of their holes. They make quite a feed. Some of our native worms can grow up to 1.5 meters long. The forest of this limestone area is very thick, concealing hundreds of cave entrances. So exploration of these caves has been fairly recent. And in 1980 at Honeycomb Hill, cavers discovered this catacomb. The area contains the most important collection of bird bones ever found in New Zealand. Leg bones and skeletons of huge flightless moa have been washed through underground passages to accumulate on the cave floor. They're about 5,000 years old and are half fossilized. They tell us a lot about the different species that for millions of years roamed the forests above. There are many natural pitfalls. Flightless birds like the kiwi, kakapo, and moa were easily trapped if they fell down one of the vertical shafts into the caves beneath. Some moa skeletons remain just as they died. Half kilos. Dinornis was the biggest moa. Like the kiwi, the moa's ancestry is still being debated. It has much in common with the cassowary and ostrich. Isolated in New Zealand, it took on the role of browsing animals like deer. Naturally enough, this weighty vegetarian needed an enormous amount of food to sustain its bulk, and it had a major effect on plants. It is thought the moor was the reason so many of New Zealand's woody plants have evolved this outside-in growth form. The succulent leaves are on the inside, protected by an outer mesh of branches. Once above moor height, the matai sprouts succulent foliage. Similarly, in the lancewood, the leaves of the young lancewood are pretty tough and beak-proof, but once it's over 3 meters high, the leaves grow broader. But the moor was not the only large bird in the forest. Among the remains at Honeycomb Hill, there were several skulls of an immense forest eagle. Haast's eagle. Probably the biggest eagle that ever flew. Today, the biggest bird of prey in New Zealand is the harrier. It hunts in the open. The adult harrier weighs in at only half a kilo. This is its skull. But Haast's eagle weighed up to 13 kilos, with talons and beak to match. Swooping down from a perch in the forest, it was more than a match for the biggest moor. But it joined its prey in extinction. "5 million years ago, the Pacific Plate grinding against the South Island started another era of land building. The low-lying islands began to rise, and the wave-cut platforms of rock were hoisted higher. The Pacific Plate continued to push against the South Island, and mountains rose. The peaks are still lifting at an astonishing rate, 17 millimeters a year. The summit of Mount Cook is now over 3,700 meters above sea level, yet its rocks began beneath the sea. The southern Alps would be much higher, but now they've reached an altitude where erosion wears away the rocks as fast as they're being lifted. The Tasman Glacier is a river of ice flowing down. At the top, the ice is nearly 900 meters thick and is still 200 meters thick at its end. The glacier is a huge land transporter, carrying a cargo of shattered rock down towards the sea. As the transition to level land is so abrupt, the rivers meander from side to side across vast beds of stone. And once again, geology has shaped a species. The wrybill, whose eggs are nearly indistinguishable from the sea sediment stones. And the wrybill itself harmonizes with the stones among which it lives. It's the only bird in the world with a beak bent to one side. The reason for such a beak becomes obvious when you see it feeding. This charming wader can reach around the underside of stones to remove insect larvae. The fast-flowing streams and rivers that start in the southern Alps have influenced another species, the blue duck or wheel. They're usually found in pairs, shoveling in white water for the larvae of the caddisfly, mayfly and stonefly. The black flaps of membrane on their bill protect the edges as they scrape the larvae from the rough rocks. The blue duck has been isolated for so long, it has no close relatives anywhere. But the most powerful force influencing the recent evolution of New Zealand's plants and animals has been the changing climate. The ice ages. Temperatures dropped. Ice gripped much of the land. New Zealand may have gone through as many as 20 ice ages or glacials in the last 2 million years. Glacial times were extremely difficult for all living things. Where trees died out or retreated, tussocks spread across the foothills of the South Island. But many species coped well with the changing climate, like the takahe, which nests beneath the snow amongst snow tussock. And the sturdy, flightless bird actually regenerates tussock growth. It eats the base of the tussock stem, which is rich in sugars. Unlike today's browsing animals, which reduce the plant to a stubble, the takahe promotes tussock growth by pulling out the tillers, which stimulates the plant to grow more. Forests were hard hit by the cold. Southern beech, which had flourished for millions of years in the cool, wet climate, shrank before the ice. And insectivorous birds like the bush robin were losing their home. They were now confined to the small remnants in sheltered valleys. Some birds evolved to suit the changing environment. The rifleman is the smallest bird in New Zealand. It comes from a very old family. One of its ancestors also gave rise to the alpine rock wren during a glacial period. As the snow thaws, it builds its nest in crevices among rocks, and during the winter, it actually lives under the snow. Also here, before the cold, was a lowland parrot. It has since survived the effect of the glacials in the North Island as the kaka. But in the south, where snow invaded, displacing forests, the ancestral parrot found a new way to live in the cold, bleak land. It became the kea, the only alpine parrot in the world. With its long beak, the kea has no problem digging out succulent roots and shoots. They waddle and hop across the snow, eating almost anything, as most trampers are aware. They'll even undo packs with their beak to see what they can find. They nest beneath rocks, above the bush line, and a male may have 2 or more mates nesting at the same time. Kea are cheeky, playful birds. And they're very intelligent and resourceful. Perhaps that's the secret of their survival. In colder areas, many species tend towards melanism. Many alpine insects are black. The Pluto butterfly presses its wings close to the sun-warmed rocks. It absorbs heat and avoids the chill wind. As the Alps rose and the ice came and went, plants too had to adapt or perish. Many made the change, like mountain buttercups, South Island edelweiss, and many varieties of white gentian. Spear grasses like golden Spaniard are of the carrot family. They flourished. There are 39 different varieties in New Zealand. Mountain daisies, easily windblown, were scattered through the mountain ranges. When the ice last retreated 10,000 years ago, the forest crept back up the sides of the great U-shaped valleys which had been carved by the ice. As the climate warmed, the ice slowly melted and flowed to the ocean. Sea levels rose, drowning the valleys to form deep fjords. These islands in Fiordland were once beneath 1,000 meters of ice. The ice has gone. The old rocks await the next move. Most of New Zealand's geological events have occurred very slowly. But as we've seen, geological forces can act suddenly and catastrophically. White Island steams menacingly in the Bay of Plenty. It stands alone at the northern end of a line of fire called the Taupo Volcanic Zone. It's our most active volcano, a lively reminder of what's going on underneath us. Steam and sulfur dioxide gas stream into the atmosphere from numerous vents. It's a hostile place for living things. It would be suicidal to try and stand here. The steam is pungent and corrosive. Some of it erupts at 800 degrees Celsius. The escaping gas deposits crystals of sulfur around the edge of fumaroles. An eruption in 1978 formed a new crater. It descends 115 meters below sea level. A new eruption began in 1986 and has carved another active vent in the crater. White Island is direct evidence that the Pacific plate of the Earth's crust is diving down beneath New Zealand. A line of volcanoes extends southwestward from White Island, paralleling the collision zone between the plates. The lava domes of Tarawera formed 700 years ago, but on the night of the 10th of June 1886, a new fissure opened. For several terrifying hours, scoria and ash burst out, devastating 3 villages close to the volcano. The Mount Tarawera eruption blanketed this area of the Bay of Plenty 10 centimeters deep in ash. But it was a small eruption compared with those of Taupo. Just one of them, 20,000 years ago, exploded a mixture of fresh magma and lake water and covered an area of this size with ash. On a world scale, this is an extremely active volcanic zone. The next major eruption at Taupo threw an incandescent cloud of ash and gas over a 100-kilometer radius, carbonizing whole trees and devastating forests. This eruption, only 1,800 years ago, was small for Taupo, and yet was 30 times bigger than the famous Mount St. Helens eruption in 1980. A million years of volcanism have gone into building up the volcanic plateau of the central North Island, and the volcanoes of this area still pose substantial risk. The vast heat generated by the descent of the Pacific Plate also surfaces as the geysers and hot springs of the region. Immense forces are waiting beneath the Taupo volcanic zone. The heat which keeps this stream at 55 degrees Celsius modifies the climate, allowing delicate plants to thrive outside their normal range. This natural heating system nurtures warm-blooded immigrants to New Zealand. Welcome swallows came from Australia in 1958. They congregate in the steam to escape the winter chill of their new southern land. They're just one of the many species of plants and animals to arrive here in the 80 million years since New Zealand was set adrift. From Stewart Island to Northland, volcanism has shaped many parts of this land of the Kiwi. Rangitoto erupted only 300 years ago. It's still being colonized by trees. Another 47 cones and craters lie nearby, under the suburbs of Auckland. These volcanic cones are different. Set well back from the edge of the Pacific Plate, they were built up by primitive magma. Auckland eruptions are small in comparison to the giant calderas of the south. Little comfort in what is now a heavily populated area. As Auckland is situated over a hotspot, there's every possibility that new cones may appear in the next 1,000 years. We'll have to live with it. The way the Kiwi has had to adapt to this changing land and our arrival. In the past 1,200 years, we've had a more devastating effect on the wildlife and forests of New Zealand than 80 million years of natural change. In the future, we may all have to face some rather forbidding challenges. We've not yet seen the last of dramatic geological changes in this land adrift.